Welcome back to eCoreAcademy, students. My name is Anita Raj, and today I'm bringing you the third and final video in our miniature unit on three-variable systems. So to access the previous two videos, please check out the Algebra 2 playlist I have up on the channel. The first one is a review of two-variable systems, and then we do an introduction to three-variable systems, as in solving them by hand. My last video, as in my second video on three-variable systems, was using the Texas Instrument calculator and using the matrix on that calculator to have the calculator compute the solution set to your three-variable system for you. So you don't have to do it by hand if you have that calculator. And lastly, today's video will be doing an actual word problem as in an application, so you guys can see how we use these three-variable systems in real-life scenarios. And it's a pretty cool application I have prepared for you guys today. Before we even get into the video, please pause, like the video, and subscribe to our channel if this video benefits you at all, because we have tons more like this. So you guys, if you're benefiting from this, please subscribe. You'll get notified of all our future videos, so you can follow along with these courses, especially this Algebra 2 course I'm doing, because I know that it'll help a lot of you guys. Also, hit the notification bell to be notified, and share our videos and our channel on social media platforms. They're all in the description box below, so check them out after the video. Without further ado, let's do an application as in a word problem together right now. So again, today we're going to do real-world applications. Applications are just another word for word problems. So let's see how this concept of three-variable systems appears in daily life word problems. So it's always important to know how these concepts that we learn in Algebra 2 or any other course you're taking apply to real life. Like I told you in my Introduction to Algebra 2 video, I would always try to give you some kind of application. Even if I didn't tell you straightforward, it would come in the form of a word problem. So we'll see how these three-variable systems are used in real life. Okay, so this is the application I have for you guys today. I'll read this mini paragraph for you guys, and then there's some guidelines at the bottom, and then we'll get right into the problem. So here's the application. A box of wood pieces contains wood cut into triangular, square, and pentagonal shapes. There are 80 pieces of wood in the box, and the pieces have a total of 290 sides. If there are 10 more triangular pieces than square pieces, find the number of pieces of wood of each shape in the box. So that is a pretty hefty paragraph. Whenever you're approaching really long word problems like this, especially if you're doing them on the SAT, what you want to do is you want to organize your important information. So here, let's organize this important information by summarizing ourselves. So there's a box of wood pieces. In this box, you have three types of wood pieces. You have triangular wood pieces, square wood pieces, and pentagonal wood pieces. There's a total of 80 pieces of wood in the box. So this is triangle, square, and pentagonal shapes. There's a total of 80. And if you count the sides of every piece of wood, you'll see that there's a total of 290 sides in the entire box, accounting for all these pieces. And the last piece of information we get are that no matter whatever amount of triangular pieces we have 10 more of triangular pieces than square pieces. So if you have square pieces, if you call that x, you have 10 more triangular. So x plus 10 is your triangular pieces. That's our last piece of information. So now, given this information, we need to find the amount of triangular pieces in the box, amount of square pieces in the box, and amount of pentagonal pieces in the box. So that's how you would break the problem down in your own head. So before I even get into the solution I have prepared, I want you guys to remember that you can do this by hand. And actually on the next slide, I'm going to show you how to do this by hand, because I realized that I put a lot of emphasis on the TI calculator, but I keep emphasizing, like my math teacher said in class, everything can be done by hand. So I'm going to show you how to do this by hand. You just want to write your three equations down. I'll show you how to derive three equations to make a three-variable system from this word problem, and then you just use the process of elimination like we usually do with three-variable systems. And then on the last slide, I'll be showing you how to do this with a TI calculator. That'll be super easy, and we can just breeze through that. So without further ado, let's get into the first section, where we'll be doing this by hand. So give me a second. I'm going to switch to Microsoft Paint. So I'm going to switch to Microsoft Paint so that I can show you guys how to do this. So I have Paint up, and I'm also going to use a pad so that I can draw this out for you guys. So if you see here, I have the exact same solution I actually have on my slide. So if I exit out of the Microsoft Paint, you'll actually see the same solution on the slide. And you can see everything written out. I've already pre-written it out because it's a pretty long solution, but I'm also just going to highlight key points as I walk you through the solution. So again, this is by hand. If you see, I've set it up like a normal three variable system. If you guys remember my first video, this is how I wrote out the solutions. So let's look at how I wrote this out. So first, I want you guys to take a look at right here. I'm going to underline it. So I said eliminate y's right here at the top. So first, you want to write down your three equations. So I wrote my first one, second one, third one. So I derived this from the actual problem. I'm going to be showing you on the next slide with the TI calculator how I found these equations, but trust me, if you get used to it, you'll be able to find these equations. So remember, you have triangular, square, and pentagonal shapes, right? And total is 80. So X represents your triangular, Y represents your square, and Z represents your pentagonal. So together they all should be equaling 80. That's the total amount of actual shapes in the box. So that's how you get this first equation. The second one, they say a total of 290 sides. Well, how many sides does a triangle have? 3. How many sides does a square have? 4. And how many sides does a pentagon have? 5. So if you put this coefficient in front of X, it counts for how many sides. So this is how X corresponds to how many actual triangles you have, Y corresponds to how many squares you have, and Z corresponds to the pentagons. By adding these coefficients, you're compensating for their size. So this is the second equation. And the third equation, they said that we have 10 more triangular pieces than square pieces, and if Y is square and X is triangle, then Y plus 10 is X. That should be pretty simple. So let's actually get into solving this together. So first, you want to pick two equations. I picked the first one and the second one, and you want to do elimination method with them. I decided again up here to eliminate the Y's. So again, eliminate the Y's. So that's what I chose to eliminate. So I wrote them both down right here. So the first equation is X plus Y plus Z equals 80, and the second one is 3X plus 4Y plus 5Z equals 290. So what I need to do is to eliminate this Y. Let me look at this Y right here. It's a positive 4 coefficient. So what I want to do is I want to multiply this Y by negative 4 so I can eliminate this Y. So I multiply the whole top equation by negative 4, as can be seen right here. And I multiply this by negative 4, and I get negative 4x minus 4y minus 4z equals negative 320. And then I just add this equation right here to this equation right down here. And by adding them, negative 4x plus 3x is negative x. Negative 4y plus 4y just cancels out. And then negative 4z plus 5z is plus z, just positive 1 coefficient. And this equals negative 320 plus 290, which is negative 30. So this right here is our fourth equation. So if you guys remember, we repeat the same process, but we pick a different set of two equations from our original system. So I picked the second and the third equation, and I put them right over here. So the second equation is 3x plus 4y plus 5z equals 290 again, and the second one is x equals y plus 10. I simplified this into the same form I have here by just subtracting y from both sides. So the new equation will be x minus y equals 10. So then I wrote that down here. And what we have to do is, again, we have to eliminate the y's. So I look at this y right here from the second equation. I have 4y here, and I have negative y here. So to get rid of the y, I need to multiply this whole equation by 4 so I can get a negative 4y, and the y's cancel out. So I multiply this whole equation here by by 4, positive 4, and I get 4x minus 4y equals 40. And then I add these together. 3x plus 4x equals 7x. 4y minus 4y just cancels out. And lastly, you just have 5x, so you bring it 5z, so you just bring it right down here. So that's that. And then finally, you have 290 plus 40, and that equals 330. So this will be your fifth equation. So then we have to just go down here, and we have to add the fourth equation and the fifth equation together. So again, the fourth equation is negative x plus z equals negative 30, and the fifth equation is 7x plus 5z equals 330. So what we have to do here is we have to pick another variable we want to eliminate. In this case, I decided to eliminate the x's. So if you see here, I analyzed this second equation. I have 7x, so I decided to multiply the top equation by 7, so I get a negative 7x, and the x's cancel out. So I multiply the top by 7, and I get negative 7x plus 7z equals negative 210. Then you add these two together, and this x's cancel out. 7z plus 5z is 12z, and negative 210 plus 330 is 120. So you get 12z equals 120, and then both sides divided by 12, then you get z equals 10. So you found out the first variable, z equals 10. Again, z is our pentagon, so we have 10 pentagons. We want to plug this into either the fourth or fifth equation to find what x is. X is our triangles, and I decided to plug it into the fourth equation. So I just took the fourth equation and substituted. Remember, this is z, this is our pentagons. I'm just going to write that above it. Pentagons. Yeah. And then we substitute that in, and negative x plus 10 equals negative 30. Negative x equals 140 because we subtract 10 from both sides. X equals 40. So this would be our triangles. So now we found our triangles. And lastly, we want to pick the first, second, or third equation that has a y in it so we can find out the amount of squares we have. So then what we did was I picked the third equation, which is the simplest one of the three. And then I just come down here. And I just plugged in 40 for x because it's x minus y equals 10. Plugged 40 in for x. Then you have negative y equals 10. Then you subtract 40 from both sides to get y by itself. You get negative y equals negative 30. Multiply both sides by negative 1, and you get y equals 30. So this quantity would be the amount of squares you have. So squares. And lastly, if you come over here, I summarized it for you. So the ordered triplet will be 40, 30, 10, because you remember x, y, z, and then x equals 40 triangles, y equals 30 squares, and z equals 10 pentagons. So this is your final answer, and that's how you would have gotten there if you followed that. So that's how you would do it by hand. And now let's exit out of this screen. Give me 1 second, guys. Okay, so if you just want to pause the video and look at this screen right here, this is the solution, same thing. You can just go over that if you want to. But the next screen I'm going to go to is the calculator. So let's look at the calculator. Let me actually pull up the digital calculator TI emulator I have now. So it's right here. 1 second, guys. Give me 1 second. Okay. So now I have the emulator up, and what this is pretty much you download the software onto your laptop, and you actually have a digital emulator. I'll actually put the link in the description if you want to try it. You don't need an actual calculator, but you have to purchase this after your 90-day free trial. So again, it's an emulator. It's right on your laptop, and it's really useful, especially for these demonstrations. I realized we got an emulator for my laptop, so I can demonstrate this to you guys on the actual screen, so it's easier for you to see it no matter what device you're viewing it on. So now we're going to be doing the exact same thing we just did. We're going to get the exact same answer, but we're going to be doing it on the calculator. So this is a TI-84 Plus CE version, and you have different versions, but this is the one I would recommend because if you guys remember my calculator, this is the exact same software as my calculator. So what you want to do now is you want to take the same approach. You want to assign your variables. So like I said before, x is our triangles, y is our squares, and z is our pentagon. So we assign each of our variables with the corresponding shape of wood. Then we're going to write our three equations. If you guys remember, it said we have a total of 80 shapes. So the amount of triangles plus squares plus pentagons is 80. So we do x plus y plus z equals 80. The total is 80. Next, it said there's a total of 290 sides. Well, triangles have 3 sides, squares have 4 sides, and pentagons have 5 sides. So you put those coefficients in 3x plus 4y plus 5z equals 290. Because for each shape, you have to compensate for its sides. And lastly, we have 10 more triangular pieces than square pieces. So x, which is our triangles, is equal to squares plus 10. That's our simplest equation. We write that down. We have it done. So now we want to input our values into the matrix. So if you come over here to this calculator, I'm going to show you how to do it on this emulator. So in order to access the matrix, you want to hit second, and then you want to hit x to the negative 1, and you'll be taken to this screen. Then you want to hit the right arrow twice to go to edit, and then you want to hit 1 to go to your matrix A. This is a review from our previous video. And then you want to have the dimensions 3 by 4. You want to hit the right arrow and type forward. And if you hit the down arrow, well, your matrix is all set. You have a 3 by 4 grid. Now you want to look at these three equations we have right here, and you want to input them into the matrix. So the first equation is x plus y plus z equals 80. Well, all the variables have a coefficient of 1, so I'm going to be typing 1 into each of these slots in the top row. So each one is positive 1. And then this equals 80. So in that last slot in the top row, I'm going to be typing 80 in. So my first equation is set. So let's do my second equation. My second equation here is 3x plus 4y plus 5z equals 290. Well, the coefficient of x in this case is 3, positive 3. So I'm going to type 3 in. Then the coefficient of y is 4, so I'm going to type 4 in. The coefficient of z is 5, so I'll type 5 in. And then this all equals 290. So I'm going to be typing 290 in. So the second equation is already set in our calculator. Let's look at the third equation. So this is x equals y plus 10. If you guys remember from last time, we subtract y from both sides. We get x minus y equals positive 10. So we're going to be looking at that version, x minus y equals 10. So our x coefficient in this case is a positive 1. If we look at the equation x minus y equals 10, we actually have a negative 1 coefficient, and then we don't even have this we don't even have a z in this equation. So x is equal to, the coefficient of x is 1, coefficient of y is negative 1, and then lastly, the coefficient of x would be 0 because there is no, the coefficient of z would be 0 because there is no z in this case. And this all equals positive 10. So now our matrix is set. Afterwards, we just want to second mode to quit the screen. Then we want to do second x to the negative 1 again. And then we want to hit right to go to math, and we want to scroll down to BRRF. So we're going to scroll down, and I'm on BRRF, then I hit enter, and I'm taken to the home screen again. Now we want to select our matrix A, so second x to the negative 1, hit 1 to select matrix A, and then just close parentheses, and if I hit enter, I should get the exact same answer, which I did. So this, remember guys, this is the last column. That's what you're looking at for your answer. So 40 is your x coordinate, y coordinate, and then z coordinate. So it's written right down here on the screen. X equals 40 triangles, y equals 30 squares, and z equals 10 pentagons. So that's how we solved this using a emulator, using a TI calculator. So you can get the exact same answer with a calculator. Even if you do it by hand, it doesn't matter. Again, calculator is going to be faster, but you can do the exact same thing by hand if you follow the steps that we reviewed in the first video. So that's all I have for you guys today. I hope you enjoyed it, and please drop a comment about what you felt with the TI calculator emulator on my computer versus me putting the calculator on the webcam and the actual writing pad I had in the Microsoft Paint. We really want to know about those. I hope you guys enjoyed this video and saw how we apply these 3 variable systems to actual life. There's so many more problems, but I won't be able to touch base on them with you guys. But again, you can find them online, so many different scenarios where you use these 3 variable systems. So please look into our website, which is going to be going up soon. The link is here and in the description box. It has so many materials we don't have on the YouTube channel. Obviously, PDFs of notes, exclusive notes AJ and I have, quizzes AJ and I have made, kind of preparation for assessments with these different concepts we're teaching you. Also, we have a Facebook, Instagram, and Twitter. Please check those out. If it's easy for you to share eCoreAcademy with friends that way, please look into those. And like this video and subscribe to our channel. If you found this video beneficial and you found other videos beneficial, please join the community. We are open to all of you guys who are looking for more videos and looking for support, especially during COVID. And lastly, we have a Gmail account. So if you guys have any personal or business correspondences you'd rather not put in the comments, please contact us that way. All right, guys, please stay safe during this COVID situation, and I'll get back to you with another video soon.